So in this video, I'm going to discuss a trick to find bond order. So here I'm going to discuss three different formulas. Formula number one, so bond order is equal to 1 plus the number of pi bonds divided by number of sigma bonds. That's the first formula. Bond order equal to 1 plus number of pi bonds divided by number of sigma bonds. Then formula number two, bond order is equal to number of bonds between two atoms in all resonance structures. Number of bonds between, total number of bonds between two atoms in all resonance structures divided by total number of resonance structures. This is the second formula. The third one, bond order is nothing but the total number of bonds divided by number of bonded groups. Okay, so now we are going to use all these three different formulas to calculate bond order of certain species. Okay, right. So now let us see an example. Example number one, carbonate anion, formula C minus. Okay, so I have drawn the resonance structures of carbonate anion. First method, the formula is nothing but 1 plus number of pi bonds divided by number of sigma bonds. I calculate bond order of carbonate anion using the first method. 1 plus in this structure, so this is a sigma bond, isn't it? Single bonds are generally sigma bonds. Double bond, among the double bond, one is sigma bond, another one is pi bond. So totally there are 3 sigma bonds and 1 pi bond, isn't it? Therefore, in the first method, 1 plus number of pi bonds divided by number of sigma bonds. 1 plus number of pi bonds 1 divided by number of sigma bonds 3. So that we get 3 plus 1 by 3, 4 by 3. So that I am getting bond order about 1.33. Okay, right. So this is the bond order of carbonate ion by first method. Okay, right. Whereas in the second method, the formula is number of bonds between two atoms in all resonance structures divided by total number of resonance structures. So second method, number of bonds between two atoms in all resonance structure. Okay, right. Now, so there are 3 resonance structures for carbonate anion, isn't it? Right, now you have to consider similar positions, just like this. The number of bonds between two atoms in all resonance structures. The first structure 2, second one, third one. For 2 plus 1 plus 1, 4 divided by the total number of resonance structures. So resonance structures form 1, 2 and 3. The total number of bonds between two atoms in all resonance structure is 4 divided by the total number of resonance structures 3. So I am getting the same 1.33. 4 by 3, which is nothing but 1.33. Okay. The third method, the formula is total number of bonds divided by number of bonded groups. Total number of bonds divided by number of bonded groups. For example, when you take this structure, the total number of bonds 1, 2 plus 2, 4. That is 2 plus 1 plus 1. That is 4 divided by total number of bonded groups. So this one can be considered as one bonded group. This is the other one, second one. Then this is the third one, isn't it? So the total number of bonded groups 3, 4 by 3. So we are getting the same. Okay. So all the 3 formulas will give same bond order for the carbonate anion. Another example is nothing but nitrate anion, NO3 minus anion. Resonance structures. So nitrate anion also has 3 different resonance structures like this. Okay, right. The first method, according to the formula, 1 plus number of pi bonds divided by sigma bonds, isn't it? Whereas these two are nothing but sigma bonds. Whereas double bond law, one is sigma bond, another one pi bond. Upper total number of bonds 3 sigma bonds and 1 pi bond. Formula 1 plus the number of pi bonds 1 divided by number of sigma bonds 3. So that 4 by 3 I am getting the same 1.33. Okay. Similarly, the second formula. The second formula is nothing but number of bonds between two atoms in all resonance structures divided by total resonance structures. Number of bonds between two atoms in all resonance structures. Now you can consider these location. Here 2, here 1, 3, here 1, 4. 4 divided by total number of resonance structures is about 3, 4 by 3. So you are getting 1.33. The third formula, the total number of bonds divided by number of bonded groups. Total number of bonds divided by number of bonded groups. Total number of bonds 4, isn't it? Because there are 2 single bonds and a double bond. The total bond together here 2, 1, 1. So 4 divided by number of bonded groups. So this is 1. Similarly, this is another bonded group 2. This is the third one, isn't it? But total number of bonds 4 divided by the number of bonded groups 3, so 1.33. So that like carbonate anion, even nitrate anion also has same bond order 1.33. Okay, right. The next example is benzene. Next example is benzene. This is a structural formula of benzene. So we have 6 carbon-carbon single bonds and 3 carbon-carbon pi bonds, isn't it? So here you have 6 carbon-carbon single bonds, 3 carbon-carbon single bonds, isn't it? Then 3 carbon-carbon pi bonds. Okay, so just remember this number of bonds, right? And now so these two are nothing but resonance structures of benzene. So that when we apply the first formula, 1 plus number of pi bonds is about 3, isn't it? Divided by sigma bonds between carbon and carbon 6, about 3 by 6. So you are getting 1.5. Okay. When we apply the second formula, that is the number of bonds between two atoms of all resonance structures divided by the total number of resonance structures, number of bonds between two atoms of. So let us consider this position, carbon and carbon. So here 1 bond, here 2 bonds, isn't it? But therefore number of bonds between two atoms in all resonance structures is about 3. And total number of resonance structure is about 2, 3 by 2. So you are getting 1.5. Okay. Third formula, the total number of bonds divided by the number of bonded groups. Total number of bonds divided by number of bonded groups. Here total number of bonds 6 plus 3, 9. That is 6 sigma bonds between carbon and carbon, 3 pi bonds between carbon and carbon. 6 plus 3, 9. That is the total number of bonds divided by the total number of bonded groups. Total number of bonded groups. So this is 1. Likewise, another bonded group 2, 3, 4, 5, and the last one is 6. So total number of bonded groups about 6. 9 by 6, so you are getting 1.5. Okay, so this is how to calculate the bond order of the species molecules as well as ions. Okay, right. Now we are going to discuss some problems which are based on bond order. Okay. Arrange the following species in the decreasing order of bond order. You are given carbon monoxide, carbon dioxide, and a carbonate anion. Okay. So carbon monoxide has resonance structure of C triple bond O, isn't it? Right. And the triple bond, one is pi bond, the other two are sigma bonds. So there are 2 sigma bonds and 1 pi bond between carbon and oxygen. So when you apply first formula, 1 plus the total number of pi bonds is about 2 divided by, total number of sigma bond is about 2 divided by total number of pi bond is about 1. So there is a formula, isn't it? First formula, number of pi bonds divided by number of sigma bonds, isn't it? But number of pi bonds 2 divided by number of sigma bonds 1. 1 plus 2 is nothing but 3. The bond order of carbon monoxide is about 3. Then carbon dioxide, this is a resonance structure. There are 2 double bonds between carbon and oxygen on either side, isn't it? Among that, one is sigma, another one is pi. For each double bond consists of 1 sigma bond and 1 pi bond, isn't it? So that first formula, so bond order equal to 1 plus number of pi bonds 2 divided by number of sigma bonds also 2. 1 plus 1, 2. Okay, so that bond order of carbon dioxide is about 2. Okay, right. Then the next one, carbonate anion. So this is the resonance structure of carbonate anion. As usual, the first formula, 1 plus number of pi bonds. Here this is sigma bond, this is also sigma. In the double bond, one is sigma, another one pi. 1 plus number of pi bonds 1 divided by sigma bonds 3. 4 by 3, so 1.33. Okay, right. Bond order of carbon monoxide 3, carbon dioxide 2, carbonate anion is 1.33. So now we have to arrange this in the decreasing order. So decreasing order in the sense higher bond order to lower bond order. Okay, so this is the exact order. Carbon monoxide having higher bond order 3, so that comes first, followed by carbon dioxide with bond order 2, then the last one with least bond order 1.33, which is nothing but carbonate anion. Okay, right. So likewise, one more question number 2. Arrange the following in the increasing order of their bond order. So you have to arrange in the increasing order, lower bond order to higher bond order. Okay, right. Nitrogen monoxide, nitrite ion and nitrate ion. Okay, NO2 minus nitrate ion, NO3 minus nitrate anion. Okay, right. So now first let us calculate bond order of nitrogen monoxide. So this is based on normal calculation. Okay, based on number of electron in bonding molecular orbital and anti-bonding, whereas in nitrogen oxide molecule, nitrogen monoxide molecule, the number of electrons present in bonding molecular orbital 6, anti-bonding 1. So the formula Nb minus Na by 2, 6 minus 1 by 2, 5 by 2. So I am getting 2.5. That's the bond order of that nitrogen monoxide or nitric oxide. Okay. Similarly, NO2 minus. So this is a resonance structure of NO2 minus ion. Okay, right. Now when we use that first formula, 1 plus number of pi bonds 1 divided by sigma bonds 2. So that 1 plus 1 by 2. So 3 by 2, which is nothing but 1.5. Similarly, nitrate anion, same formula. So 1 plus in nitrate anion, there is 1 pi bond. So already we have seen the resonance structure, isn't it? Then sigma bonds are about 3. So that 4 by 3, 1.33. Okay, right. So question is, we have to arrange this in the increasing order of bond order. Okay, least to most. So least one 1.33, that is nitrate anion, followed by the next one 1.5 nitrate ion, then finally with 2.5 bond order, higher bond order, so nitrogen monoxide. Okay, so this is the answer for the question number 2. Okay, so I hope you understood how to calculate bond order as well as how to do the problems which are based on bond order. Okay, right. Thank you, and keep watching other videos also. Thank you very much.